So just to tee up the importance and the impact of blockchain, so some statistics, one from the World Economic Forum, that 10% of global GDP will be stored using blockchain by 2027. From Deloitte Insights, blockchain technology's business value add will grow to 176 billion with a B by 2025. And finally, from Statista FinTech report, recent report, that the global blockchain technology market is predicted to reach almost 340 million USD in size and grow to 2.3 billion by 2021. So it's not a matter of if, but when. It's also, as my esteemed colleague Samson Williams says, it ain't hot sauce, you can't put it on everything. But it is important that we know the issues and that we're able to explore it, and we can speak with clients and with students to prepare them to have the discussion. Part of the competence to practice law is being technologically competent as well. So it's critically important that in every discipline, because this is such a pervasive tool, a technological tool, that we have to understand its impact in our particular field. I love this quote from Don and Alex Tapscott, because what we're really talking about is blockchain, Web 3.0. And I'll kind of take us through, most of us in this room will understand the iterations of the web from 1.0, 2.0, and now 3.0, but what that really means is that we are talking about the internet of value. We spent a lot of time, or corporations on our behalf and without our knowledge, but we certainly gave consent, building these databases of extraordinary data. We're now in a Web 3.0 world where we can talk about it as the transfer or the internet of value, and we will certainly be talking about that from an intellectual property context as well. I wanted to give you a working definition. This is a definition, and I teach blockchain and the law through our upcoming non-JD certificate program that covers blockchain cryptocurrencies in the law. And what I say in that class is that we're going to start with a definition, and it's going to change literally every time I talk to you. So we'll just write it down now, and then we'll erase it later. Are there erasers? I don't know. You'll delete it. But we have to have a working definition. But well played, well played. Pipe down. We already have our first heckler, I told you. But blockchains are, and I've highlighted some terms that are important in this space, decentralized databases. We could go on and on for 14 weeks just about that, but we won't. Maintained by a distributed network of computers that rely on network effects and economic incentives to secure the network. And so I like that as a starting point to have some grounding in the foundation as we move forward. As I mentioned, this idea of the 3 stages of computer network revolution, where you have this centralized client-server model, and that early iteration of the web, we also look at it as end users being really recipients, passive recipients. They weren't dynamically involved or socially involved in web spaces. And it's visiting a website and consuming information, but not interacting either with the information or with other peers. And then we move to Web 2.0 when we think about the decentralized structure that we've come to know and love at this point, and maybe not love so much, which leads us to Web 3.0. But we have many stop points, many intermediaries running networks that are, or communities, net communities that are connected together in the way that you see defined there. And then this idea of fully distributed, where it's the disintermediation of everything that is done on the net in its purest or ideal form. When we talk about blockchains, and each person that has a blockchain project, hopefully they'll make clear whether we're talking about a fully distributed, public, permissionless blockchain, or some type of consortium, or purely private, because it makes a difference. And that's important. But when I'm moving through these slides, I'm thinking of a public, fully permissionless chain. Where did it come from? This awesome woman named Satoshi Nakamoto. She's amazing. We don't know who Satoshi is. Many people have fun guessing who that might be, a person, a group of people, but it is interesting, and it's part of the folklore that's kind of magical. The original blockchain is the Bitcoin blockchain, as was mentioned, and Satoshi dropped this paper, this white paper, 9-page white paper, has fewer than 10 footnotes, I believe, so we are all doing something extremely wrong because that white paper changed the world. I think, he, she, they said it doesn't take all that, here's the idea. So that was written in 2008. 2009, the Bitcoin blockchain was released to the world with no intermediary governing it. It's self-executing at this point. The reason that Satoshi created it was to avoid this idea of the double spend problem, that because of, even though we have this digital veneer of how we interact with money, and there are more than a few people in this audience who probably, they have a lot of money in the bank, I think, but probably not on you, because who does that, right? So this idea that if I send money to a person, my bank has to reconcile on its end, and the other bank has to reconcile on that end, and we have all these intermediaries between the transfer of value as between us. So this digital veneer is really hiding the age-old system that we have, and so the idea was to resolve for that. The first use case is digital money or digital currency. There's some core technological components that I want you to focus on before we get into our comments. One of the many things I love about this area is that these tools have been around for decades. Peer-to-peer technology at this point, the internet, PPK, public-private key cryptography and digital signature, they've been around for decades. But it's this interesting and unique and novel way that they are working together to actually solve for some of the issues in a Web 2.0 world from an entertainment perspective. So in the copy and paste culture where you can make a perfect digital image or copy, I should say, of something and send it to thousands of your closest or not so close friends in a peer-to-peer world, actually the technology is being used now to do an end run and actually empower entertainers, creators. We're going to talk about that a bit as we move forward. So I like that idea about it as well. The core characteristics, this idea of consensus mechanisms, which we could also go on and on about for a good 14 weeks or 14 years, but it's market-based game theory. We have this app-end only nature of a blockchain. You can add to it, but you can't delete, as Steve noted. We have the disintermediation of relationships, so removing the middle person from transactions, and that's kind of the peer-to-peer part. And this idea that it's transnational, so it's borderless, which also makes it, raises some core concerns that we talk about as well. So if we have all those technological characteristics, if there's no central point of accountability and a lack of geographical boundaries, that makes blockchains really difficult to govern. Ask a legislator who, first of all, is trying to understand and grapple with what that means, and then try to regulate it. And regulate what? The tool. Intermediaries is what we did in the internet world, right? We'll just find the big guys, the ISPs, the OSPs, and we'll regulate in that space. What happens when you don't have one? The app-end only nature makes it difficult to change, clearly, unless that's hardwired or coded, I should say, into the code at the outset. Because once it's on its way, who do we call to turn it off? Pseudonymous. It is a misnomer to talk about most blockchains as being anonymous. It's pseudonymous. Ask any law enforcement personnel that's found their way to people who are defrauding others or involved in illicit or criminal activity. It's the same idea of following the money is following the public key. You can put together a whole string. So it's actually pretty bad if you plan on using it for illicit purposes. That's not legal advice. I'm just telling you what I know. And then we have something, the idea that it's transparent, it's traceable, as I'm talking about, gives plenty of concerns about privacy and what that means. So I did a presentation for a medical group, and they're very interested about the concept of using blockchain technology for certain things, but then you come up against HIPAA or GDPR, all these issues that are out in the world about privacy. And that's where consortium chains and other things come on. Blockchain mechanics, and I'm going to sit down and we'll have our other conversation. I look at it this way. I've distilled all of blockchain into one slide, maybe two. Think of it first as a digital spreadsheet of transactions that's shared across a network of computers. We're all familiar with networks and computers. Some of the language that's important in this space is that each computer that runs a full version of a blockchain's software is called a node. New transactions on blockchains are broadcast to the network, and they're verified by each node. You don't have to participate in a network as a node if you don't want to. I could have a Bitcoin wallet. Dan has a Bitcoin wallet, and we can exchange right here. But to the extent that you run the full version of the software, then your computer would be designated as a node. I'm speaking in truly broad brushes here because there are a lot of nuances to the specifics of a specific chain. We're hitting the high notes here. All of the verified transactions, and this is all done by the software, transactions broadcast. Okay, Tonya sent 2 Bitcoin to Samson. Not really, don't even look. Didn't happen. But let's say I did. Tonya sent 2 Bitcoin to Samson. Tonya has 2 Bitcoin. There might be some other rules for the protocol. The software is checking the boxes to make sure that's true, and every single node in the network does the same. That's where that consensus building comes in. There are a number of different ways to build consensus. Proof of work is probably the most prominent. Also has great concerns about the computational power that's used in energy. We could do a whole thing on the environmental law on it as well. Another is proof of stake, and there are many interesting models for that. Each group of verified transactions is called a block. You might think of it as this transactions that go on if you're a business, and at the end of the day, maybe you're making a settlement. So transactions are being verified. Does this person have the money? You're grouping or batching them all together, and a certain number of verified transactions will be recorded in one specific block. New blocks are added to the chain by a special type of node known as a miner. It's analogous. The idea is that someone goes out and is digging for gold, and then you find it. It's sometimes a bit of a misnomer, but miners are competing to solve this important mathematical equation related to hashing. And the winner, whichever miner is the first to solve this equation, is awarded with what's called a block reward. So for the Bitcoin blockchain, that's still 12.5, started at 50, and you have these halving events every 4 years or so from 50 to 25 to 12.5, and you can continue to do the math. That's not my specialty. But that person, that entity that mines successfully, and they get the block reward, and a new block is added to the chain. And how we get to blockchain is blocks are interrelated because each block contains part of the previous block's data. And so the final point that I'll make here to get a visual of how it might look, and don't worry about Merkle root, we're not going there today. But we have at the lowest level here, the block 1 transactions that are all grouped together. They're verified, waiting to be added as a new block to the chain. That is reduced down to a single alphanumeric string of numbers that is added to or combined with the hash or the numbers of the previous block. And therefore, if I wanted to change block 1, I'd have to go back to the Genesis block and do that. And with each block that's added, it gets increasingly more difficult to do that. It's not impossible. We're not talking about 51% attacks unless somebody's experienced that. I hope you have not read that. But as you can see, that then goes to the next block 2 and then block 3 and so on. And so that's basically the way the technology works and is structured.